Hey, I'm Josh. In this video, I'll be making an entire game in about an hour and a half. The reason it's so long is because I live streamed it on Twitch. If you would like to see me actually do this live, then please go follow me over there and you'll be able to see it. So, the exercise for today is to create a game that could be made on a bus or a plane where you have no internet connection and not really that much battery life. I'll be using Python and a library called Pygame, which has an API that's so simple that I can just about remember most of the important parts. So let's do it. This library called Pygame is so easy to use. I've been using it for so many years and I generally actually remember the API. It's so simple to learn and to remember. So I'm not actually sure how you would do this on Windows. Obviously there's this getting started thing and then you can just look up how to do it on Windows. Not sure, whatever. So on Ubuntu, you can simply just go sudo apt install python 3-pygame. So another thing to note is that on a bus or a plane, you actually have no internet connection most of the time, at least in my experience. So one of the main things you're going to want is documentation, unless, like me, you remember the whole API of Pygame, at least enough to actually matter. So there is also a package called Python Pygame docs or something like that. There we go, found it. So I'm going to install this package as well. I'm sure if you installed it on Windows, it would be in a folder somewhere on your computer. It's hard to say. I don't even know where those documentation files just went. So I'm going to have to look in my package manager, Python Pygame. I mean, I could search for it using my terminal, or I can just find the package and then figure out where the files went. Here they are. This one right here. So it went into user share doc python pygame html index.html. So without an internet connection, without any internet connection, I am able to look at all of the documentation of the Pygame library. So Pygame works around this idea of a surface. A surface in Pygame is actually an image that has a certain pixel size, and your job is to draw lines on it, or you could draw other images on it. So there's a function called surface.blit, which is extremely important because it lets you get one surface and draw it onto another surface. And at the root of your program will be a surface that is the actual screen itself, which is very simple to get your head around. You don't need to do any fancy graphical programming. You don't have to handle any kind of graphics APIs or texture wrangling. You just draw straight onto textures. It's very simple. No shaders, no nothing, just algorithms that you write yourself in Python. So what I'm going to do is make a directory for a game that I'm going to write. I'll call it Matcha. And then open VS Code in this folder. Actually, I wouldn't usually use VS Code because when you're trying to save battery life, you would actually want to use the lightest weight editor possible. Close your browser, close everything except for your text editor and your terminal. So in the Matcha folder, I'm going to make a new file called main.py. So the game that I'm going to make, I will draw a description of it. I'm going to just straight up rip off an existing card game that I have enjoyed playing with my friends. So the way this card game works I'm not going to name it, I'm just going to describe it. What you do is you get a deck of cards, and all the cards are circles. On each circular card, there are shapes. For example, there will be a moon, there will be a bomb, there will be a spider. So on each card is, I'm not sure how many of these shapes, but there is a whole stack of them. What you do is you deal them out, you deal out all of these cards, these circular cards, and then you leave one in the middle. You leave one in the middle, but you leave it upside down. And then as soon as you're ready, you flip the middle card upside down, and then everyone has their own little deck of cards. And what they have to do is look at the top card on their deck. It will have some other shapes. There'll be like a jug, I don't know, what are the things? There is like a sun. And what you do is you see that the middle card has a moon on it, and your card has a moon on it. And what you have to do is yell, "Moon!" And then you slap your card down on top of the middle deck, revealing another card, and foiling everyone else's plans to also match their own things. So someone else had a spider on their card, but they were too late because you slapped your card on there before this person. So I'm going to come up with a simple way to just recreate this game, but without all of the nice stuff. So one thing you'll notice in this game is that there are lots of pictures, and a bus ride or a plane trip is not really long enough to draw like 30 odd pictures. But here's a great solution to the problem. On my computer, if I go into /user/share/icons, I will find a folder full of icons. If I can actually find one. Maybe I don't have this icon set installed. I'll go into Breeze Dock. Here we go. Apps. 32. Jeez. Where are all the files? That is the question. No, that's not what I want to do. Find.pipeintegrate.png. Alright, found them. So what you want to do is find a source of a bunch of different files. So there's one in here. 16 by 16 is kind of small actually. Let's go for 64. No, 48. 48. Apps. Oh, they're all grayscale. I mean, that's not so bad. So what I'm going to do is go into my game folder, and then I'm going to get some unique symbols and jam them into this folder. Triangle, square, we've got like a plus sign, I guess. I probably want more symbols than that. Let's go into the apps folder, get like, speaker, a bell. This isn't so bad. A tick. There you go. So now I've got this little collection of quite distinguishable things. Telephone, X, magnifying glass, tick, triangle, square, speaker, bell, plus. You can name them all separately. Actually, I don't like that and that being almost the same. I'm going to delete one of them, because if you rotated it, you might not be able to tell the difference. So I'm going to put these all in a folder called images. Jam them in there. And I'm going to just rename them to numbers. That'll make it easier to code. So far, I don't actually need any internet connection, because all I need is my text editor, my terminal, some pictures I already had on my computer, and the documentation. And so here's where we get started. Once you know how to make a Pygame context, you will probably not forget it, because it's not very hard. All you have to do is import Pygame, the library, and then you go pygame.init. It's probably worth noting that Pygame is actually a wrapper around SDL, and it provides a much simpler API than the original SDL, and that's basically the idea. So this is basically a call to SDL init in C. So there's another function called Pygame display. So I'm getting autocompletion here, which basically just replaces documentation in a funny kind of way. I'm gonna make all sorts of mistakes because I haven't actually written a game in Python in quite a while, but you'll have to bear with me. So there's a library called display. Display has a function called init. Set mode, that's the one. So if you have Python, Pygame, and these docs on your computer, that's all you need. So set mode takes a Python tuple. So you just pass in something simple like 102.4.768. Actually, let's just store that tuple in a screen size variable. So now that should be enough to open a window. If I were to try and run that program right now, you see a window appear and then disappear because it opens up the window and then the window disappears. So what you should note is that set mode actually returns a surface. So I'm going to call this surface screen. So remember how I said that a screen is just a picture and you can draw other pictures on the screen. So everything, and a surface is the name for a picture in Pygame. So the screen is a surface. You can draw other surfaces on the screen. So for example, if you manage to load an image onto a surface, you can blit that surface onto the screen surface. So what I need to do now is actually load a picture. So there's a submodule called image, which will do that for you. So you go pygame.image.load. It looks like the autocompletion isn't actually working, but that's fine, because I would usually be using an editor that doesn't actually have autocompletion in it. So what you do is you pass file name to the load function and it returns a surface. It's very, very simple. So I'm going to need to get all these file names of these images. So it's just 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to make a for loop, I in range 1, 9. I forget how range works in Python. This should work just fine. So I'm going to use f strings to generate the file name. So I'm going to say i.png, and then I'm going to put images on the front. And then I'm going to make icons a list. And every time I load a picture, I'm just going to append it straight into the icons list. Let's see how that goes. Done. No errors. So now I should be able to make an event loop. So in Pygame, you're going to need to write your own event loop. It doesn't provide one, but it's very, very easy. All you have to do is say while true, and then in that loop, you go pygame.display.flip or something like that. Let's find out if I'm actually right. Yep, Pygame display flip. So what your job is to, you draw stuff onto the screen surface, and then when you run this flip function, it will actually get this, whatever you drew onto the screen, and actually put it on the screen. So up until the point when you call this function, there is nothing on the screen. So all I need to do is go screen.fill. Any surface, you can just ask it to be filled with a color. I assume I'm doing this correctly. Note that all of them are in like unsigned 8-bit integers. So it's from 0 to 255 for red, and for green, and for blue. So that's RGB in this tuple right here, and it gets automatically converted into a color internally. So hopefully, if I did this correctly, you should see a red screen. How about that? That was easy. The problem is that you can't actually close it using even Alt F4. So we're going to get to that. So before you do any drawing, what you should do is go pygame.event.get. So there are two event functions in Pygame. Let's have a look at them. We have, okay, there's actually quite a few. But we have one called get, which gets a list of events that are in the queue. So if you press a key on the keyboard, it'll get added to a list that has an internal list, and when you call get, it'll get you all those events. If there are no events, it will return an empty list and just return, and just keep going. If you say poll, it will actually give you the first event on the queue internally, and then you have to call poll over and over and over again. So generally you try to avoid poll, because if you get 100 events, that means you have to call poll 100 times. If there is nothing in the queue, it will just return none and keep going. If you call wait, it will actually do the same thing as poll, except if there is nothing in the queue, it will stop the program running immediately until an event turns up in the queue, and then peek checks if there is an event on the queue and tells you if there is one, and it does no modification to the queue itself. So what I'm going to use is get. For now, I'm going to use get. It's going to be the most expensive way to do this, because there will be nothing stopping this while loop from running as fast as it possibly can, which is not really great for your battery life when you're trying to program on a bus or a plane. But we're just going to start with that. So I'm going to make a variable called events, and then I'm going to make a for loop over the events list. So for each event, I can actually print it out. Why not? And then you can actually see what happens. If I press the control key, you see a bunch of stuff. Oh, if I move the mouse around, even better, you can see that you get events of type mouse motion, and it tells you the position, the relative movement of the mouse, the buttons that are currently pressed on the mouse, and the window that the event occurred in. So what I can do is go if event.type, and then check if it is equal to one of the several types. So what do we got? Quit. So this event is very important, because that is actually an event that appears when you press Alt F4 or you click the X on the window. So Pygame re-exports those names, I think, so you can just simply say pygame.quit, and then I'm going to just break straight out of that while loop. No, that's not going to work, sorry, because I'm actually going to be breaking out of that for loop. So what I'll do instead is I'll go running equals true, while running, and then I'll go running equals false when you press Alt F4 or press the X on the window. So hopefully, if I run this program, Alt F4, good. Click the X, good. It works now. So, So you'll note that I also can't resize the window. If you want to do stuff like that, there are flags that you can set before you create the window, and that will allow you to resize the window. Anyway, that was simple. So what I was going to mention, one thing that Pygame did not used to do in Python 2, I think, is when you press Control-C, it wouldn't quit. So you would pretty much have to use force. You would have to open up the task manager, and then you would have to find the process Pygame, and then you have to go to here and then tell it to die a horrible death. Otherwise, there is no other way to kill it, because it just intercepts all kill events and then turns them into quit events. So what I'm going to do next is draw a picture on the screen. So I have all these icons. What I'm going to do is rearrange this game a little bit. So you see what I've got here. Instead of having these cards, I'm going to have my game window. This rectangle here is my game window. And then what I'm going to do is I'm going to draw the symbols along the top like so, just with a simple for loop. And then to have two players, I'm going to have two sides. So I'm going to have the moon, the jug, and the sun over here. And then, sorry, that's not what I'm going to do. Let's try that again. What I'm going to do is go moon, jug, sun. And then I'm going to say you have to press the arrow keys to select the right one. And then this one will say, well, that might be A, W, and D for the player on this side of the screen. And then on this side of the screen, for this game to be playable, obviously you're going to need someone to be on the bus or plane with you. So this game I was making with the idea that I could play it with my wife, who was sitting right next to me on the bus. So keep that in mind for this particular game. So this one here, it will be the same. It'll have a spider, which looks a lot more like a sun than the sun itself. And then we'll have, I don't know, a skull. And then, I don't know, what else do you have? There are no other things in the world. How about a 9-volt battery? There you go, 9-volt battery. So, this one here, this person can press up, and this person can press up or left, can press W or A to match against the spider or the moon. It's okay, I have no viewers, so it doesn't really matter that I'm taking my time. It doesn't really matter anyway, does it? That's okay. So, you'll note one thing that's going to have to be done here is we're going to have to make sure that both sides have access to one of these symbols, at least one of these symbols. At the top should be one of the choices on both sides. So anyway, let's get to that game logic, shall we? I'm going to start by just drawing a picture on the screen. So I'm going to say screen. The first thing I did was fill the screen with color. That's clearing the screen. And then I'll go screen.blit icons 0. And then I think one of the arguments to the blit function on surface is source dest. So I think dest is the actual position that you want to draw it at. So let's just say 10, 10 in a tuple, which gets converted to a two-dimensional coordinate in pixels on the screen. And so hopefully I should now see one of my icons appear. There you go. I got my telephone icon, which is number 1 in my images folder. Oh, hello viewer. Say hi if you actually want to talk to me. So, let's go over here. These icons here, I'm going to draw them at the top. So I'm going to need random number generation. So there's a library in Python called random. Obviously, finding the docs for that is going to be kind of a pain if you don't have the internet. If you have auto-completion, it would be much easier. But I think there's a function in it. Oh, there you go. It is actually auto-completing now. It just doesn't do it for Pygame. So rand_int takes two numbers. So I'm going to just pass in 0 and len of icons. And I'm not sure if that's inclusive or not. Does it actually say? Including both endpoints. So obviously I don't want to index at the length of icons because that will be out of range. So we're going to need a current state of the game. So what I'm going to do is just refactor all this stuff into a class, I think. So this is how I would write the class. Class game def init self.current. There's a list of 3 or 4 icons that go along the top here. And then we'll need one for each of the 2 players. So I'll make another class for that. Class player, and they will also have self.icons. Yeah, I'll just say icons. Whatever, it doesn't really matter. So what I'm going to do is have next turn. So every time you place one of these cards down, it reveals a brand new set of stuff. So, okay, so this is worth noting. Every time you place a card down, it replaces the top card, and that becomes the new match. So what I'm going to need to do is make it so if you press up for sun to match, oh, that's not a sun, that's a spider. Anyway, my drawing is amazing. So if you press up, then it will match against this spider, and then it will work and replace the 3 icons at the top with these 3 icons. Or if this player did it, they would take over and they would get new icons generated for them. So in the player, obviously I'm going to need a thing that generates a set of random icons. So let's say I'm going to add a down direction as well to this. So there will actually be another icon over here at the top. So I'm going to go gen icons for I in range 4 print not print, sorry. Icons is a list of icons and it will always be 4 in length. So I'll go icons.append random.randint from 0 to len of icons minus 1. And then I'll return icons. So now I can go, when you make a brand new player, I'll generate some icons. When you make a brand new game, I'll generate some icons. So I'll go players is also a list of 2 different players. And then a player needs keys that it presses. So I'm gonna make that generic. I'm just gonna say self.keys equals keys. And so what I have to do is call it with a list of key bindings. So pygame.k_w. So I'll say that keys is up, down, left, right. So up is W for the first player. Pygame.k_s is down, followed by 2 other key bindings. We've got A and D as left and right. And then the one below, we'll use the arrow keys. So I'll say k_left, up, down, left, right. Sorry, just a second. That's all right. It doesn't matter that nobody's watching because I'm just going to edit this for YouTube later. So now I've got my up, down, left, right key bindings and my W, S, A, and D key bindings for the 2 different players. So what I'm going to do now is when you have a next turn, I'll have to tell. Okay. All right. Let's see. Let's just delete this function for now. Let's put a run function in the game. And it will contain this while loop. So what I have to do now is go game equals game and then say game.run. Pretty simple. Now the game contains its own state, which is great. I'm going to put that running variable inside of game just because it seems like it belongs there. Running equals true. And then I'll go while self.running, and then when you quit, it says self.running to false. So hopefully, Line 48, line 16. So it says empty range for rand range. Empty range. See, that's unusual. Now, why would that be empty? Tell me that. I actually don't know. Let's just print stuff out. Print line of icons, I guess. Line of icons is 0. Now that is interesting. Ah, of course. Right, I've got a local variable called icons. Ah, classic. So, I'll just call that new icons. Problem solved. New icons, new icons. There you go. No attribute k_w. Now that's also interesting. Because it's lowercase. There you go. So all of the key names are under capital K underscore lowercase letter number. I almost just made a mistake there because that should be KW, KS, KA, and KD. Alright, now we've got our players. How long have we taken so far? The bus ride isn't over yet, is it? I'm not really sure. how long this stream has been going for. Oh, there we go. It's at the top. 43 minutes. So the bus ride probably still has quite a while to go. So let's keep going. Now I have new icons, and I'm going to have to draw these icons on the screen. So currently I have this blit function. I'm going to have to draw the icons in the game, the current icons. So for each icon in that, for I in range len current icons, and then I'll get each icon and draw it at a very specific position, depending on the index. So let's draw the icon with a y coordinate of like, I don't know, 50, and an x coordinate of 200 plus 200 times I. Let's see how that goes. That did not work. Well, I did not mean to append... No, I did mean to append an integer, but what I need to actually do is look up... Oh, okay, this is a better idea. Icon images. I'll rename it to icon images, and then I can just use that. So I'm going to have to go current icons at I, and then I'm going to have to look up the image associated with that icon index. So I'm going to call that icon image, and I'm going to blit it on the screen at a very specific x coordinate. Still doesn't work? Ah, right. So this needs to depend on the number of icon images. There you go, look at that. That's exactly what I wanted. So, it's a little bit off center, so I'm just gonna change that to 180 as the left. There you go, they're nice and centered. That red is a little harsh, so I'm just gonna draw a white background. There we go. Okay, so now we have a different problem, which is that I'm going to need to change this a little bit. So while new icons dot len is so I've been writing a lot of Rust lately. Length of new icons is less than 4. I'm gonna have to go I is a thing, and then index. So the problem was that there were more than one of the same symbol, so I'm going to have to make sure that that doesn't happen. So I'm just going to continuously generate random numbers until I find one that is not in the list already. So I'm going to say if index not in new icons, so that will check if it's actually contained in the list yet. So if it's already in the list, it'll skip this and then it'll go back to the while loop, and it will just keep going until there are 4 icons in the list. Let's see how that went. There you go. Now every time I run the program, the icons are completely unique from each other. Obviously if I had less than 4 icons, it would just loop forever and the program would just straight up break. Alright, so now that I have new icons, how's the bus ride going? Only 47 minutes. That's fine. I only started at like 7 minutes in, so it's only been a 40-minute bus ride so far. So what I need to do is look for key presses. So elif event.type is pygame.keydown. And then, if it's a key down event has a thing called key code or something in it. Let's look at our offline documentation again, shall we? Event. Let's have a look. What was I looking for again? Ah, yes, key down. So when you get a key down, the following things are available: Unicode, key, and mod. What we want is key, because that's an integer that represents the actual key code. So I'm going to have to go through all the players and figure out who the key code belongs to. So I'm going to go for player in players, and then I'm going to go player.keys. I'm going to loop through the keys by index key index in range of len of keys. Well, I'm just going to go range 4 because there's always 4 keys. So I'm going to go for key index in range 4 event.key. I lost my train of thought. Right, so I'm going to go player.keys indexed at key index, and so that will tell me if event.key is that, then I'm going to say that, okay, what I'm going to have to do is, there's a function in Python called enumerate, which is extremely useful because it returns both the index and the item itself from the list. So I could have actually used that right there, but whatever. Why not? Enumerate player.keys. So that will give me key index and the key itself. So if the event key is the correct key, then I'm going to tell the game that player played, and then I'm going to tell it the player index, and I'm going to tell it the key index, which is associated with the actual direction that they pressed. So this function obviously doesn't exist yet, so let's make it. So the arguments were player index and key, and I'll just call it dir, because it's an integer that represents the direction that was pressed. So let's go, so when they play, what we have to do is verify if it was a valid play or not. So I'm going to assume that it's invalid by default, because the assumption is that none of them match, and then we have to prove that wrong. So what we're going to do is go self.players at player index, and assign that to player, and then the player has this list of icons in it, where the player class has this list of icons, which is a list of integers. Let's make that clear. So I'm going to get the icon associated with the direction that was pressed, and then just remember that's an integer. So I'm going to go if if that integer index, icon index, let's call it that, why not, icon index. If that icon index is found within self.icons, then it's a valid play. So I probably don't really need this, because I was planning on doing a for loop, but I probably don't need to. So this is when the move is valid. Oh yeah, so we're going to give the player a score. Starts off with 0. So when the move is valid, we're going to go we're going to go player.score plus equals 1. So you get 1 point every time you make a valid move. If you make an invalid move, it's going to subtract 2 points. So it's really not a good thing to make the wrong move. So when you get a valid move, what I will have to do is go self.icons is actually the player's icons, because it's equivalent to them putting their card on the middle deck. So this list in game, current icons, self.current icons. So this list in game, current icons, represents the middle deck of cards, whereas each player has their own deck called icons. So what I'm going to do is when a player gets it right, I put their icons in the middle deck and it replaces whatever's there. So currently the player is sharing its icons with the middle deck, so I'm going to make a new set of icons. Gen icons. Done. So the player has a brand new set of icons. I'm only drawing the middle deck icons currently. So what I'm going to have to do is draw the rest of the icons for the two players. So I'm going to have player centers. So the two players will be displayed with a center of like 300 by screen size y-axis minus 200 or something like that, or 300. And then what I'll do is I'll do something very similar for the other player. This will start to look like I'm actually doing something useful in a second. So player number 2 will have screen size x-axis minus 300, so that will be centered on the other side of the screen. So I'm drawing these two things. So I want to put icons here, here, and here, 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 and here, and here, here, and here. So I'm making a center coordinate for each of the two players, there and there. And then what I'll have to do is remember that the keys that you press are, let's figure that out again. I wrote it up, down, left, and right. So I'm going to need offsets, pixel offsets for up, down, left, and right. So up will have no offset on the x-axis, and then, worth noting in Pygame, 0, 0 is the top left of the image. So what I'm going to do is go 100. So that means that negative y is actually up, which is different to a lot of game engines. So I'm going to go up, down, also has 0 by 100. Left is going to be minus 100 by 0, and then right is going to be 100 by 0. So I'm going to go player. So for each player, what I'm going to do is go player index enumerate players, self.players. So for each player, I'm going to get, sorry, I need to also have that. So I have the index and the player for each player in the list. So I'm going to go player centers at player index. So here's the center associated with this player. And then I'll need to do something very similar to this up here to draw the center card icons. But instead I'm drawing them for each player, so I'm going to have to go, I'm going to write a for loop. Oh look, I did it again. I'm going to use enumerate here as well. Icon. Image. That's better. And then I'll do the same sort of thing down here for each player. I'll loop through all of that player's icons. And then, alright, so now I'm going to draw each icon on the screen at a very specific coordinate defined by center. I think Pygame actually provides a vector type, but I'm not really sure. It would be nice if they had a vector type. I haven't used it for so long that I actually can't remember. Oh, here we go. Here we go. There we go. So I'm going to import this class right now. Just directly import Pygame math vector 2 so that I can use this whenever I want. So I'm going to go vector 2 of center because I'm lazy and I don't want to surround all of those with vector 2. I could use a map. Whatever. Doesn't matter. This is like supposed to be done in a short amount of time, so we can't really waste time. It's already been an hour, so the bus ride is well on its way and our game isn't even playable at all yet. So let's do this, shall we? I don't think I did that right, but... Oh yeah, Python has like the weirdest import syntax ever. There we go. No. Other way around. From vector 2, import. I completely did it the opposite way around. Twice in a row. I'm so not used to Python. Alright. There we go. Okay, so what do we got? On line 65, we will have a blit. Uh-oh. Don't tell me that enumerate does the opposite order, so I'm going to have to rearrange all of these for loops that I wrote. Sorry about that. I wish I had some viewers right about now because they probably would have caught on to that before I made the stupid mistake. I would really appreciate some viewers, but that's okay. It's my first stream ever. So let's see how this goes. I think that was everything. No. It was not. See, now that's super weird. Did I save the file? Okay, I'm just going to print stuff because that's how you debug stuff in Python. Icon, image, and I. What do we got? A 0 and a 3. No kidding. I did something stupid, didn't I? Alright, I made a huge mistake. Alright. I can't use enumerate here. It doesn't make any sense whatsoever. Range of length of the current icons. So I'm going to go for I in that, and then I'll have to go icon images at I. It makes no sense to do it any other way. Because current icons is not a list of images, it's a list of indices. I keep throwing myself off there with that variable name. I should have really just called it current icon indices. But it doesn't really matter. Let's see how this goes. I'm going to have to change this one too. So that will also be range, len, player icons. And then I'm going to have to extract the actual image associated with that index. So it's going to be icon images, indexed at I, and then also we'll need the icon index. This is real confusing naming right about now, but that's okay. That's okay. Okay. So So that's confusing because this is an array of indices. So I'm extracting an index and then I'm using that index to index, and so I'm getting each index of this array 0, 1, 2, and 3, and then I'm using that to index into the index array, getting me whatever indices the icons are. Anyway, I've really confused myself here, but because I'm writing in such a short amount of time, it really doesn't matter. It really doesn't matter as long as it works. So let's get to the good stuff of interactions as soon as possible. Hopefully I changed enough stuff just then. Line 65, that should be self.current icons. No, too confident just then. Line 76. So was I right? I think I was right. The index is first. Line 80 is trying to... Let's have a look at this. Print that. So it is actually a coordinate, it's just not an integer coordinate. So I wonder if it gives me a function to get an integer version of the vector 2, because that would be really useful. Int. I guess not, unfortunately. So I'm gonna have to just, okay, so let's just, the blit function requires integer coordinates to be able to draw the picture on the screen, because it doesn't do any real-time scaling or anything. It just straight up copies pixel by pixel into the equivalent coordinates on the screen using memcopy. So it requires integer coordinates, that's all I'm trying to say. So I'll just do it the easy way. I'll just cast pos.x and pos.y to integers and see if that works. Alright. So now we've got player centers. And I'm supposed to index that at player index. Alright, so at least it ran. That's a good start. I didn't change this back after I destroyed my code the first time. Alright, so you might have noticed just then that we didn't see anything on the screen. So I'm going to have to refactor something around here. Maybe my offsets are wrong. Offset plus the player centers. Oh, well, I've got like center is already the center, so it's actually supposed to be offsets indexed at the key index. So that's, this should really be dir, just to stay consistent. There we go. All right. There, perfect. Look at that. That is great. So you can see that that player 1 is over here, player 2 is over here. I'm going to just move them apart a little bit. So that's currently 300. I'll change it to 200 on both of them. All right, look at that. So you can see the two players and their icons. So what we're going to want as well, line 56 is referring to players when it should be referring to self.players. I'm also referring to icons apparently. Line 41. Current icons. Look at that. All right. So you can see it working already. It is almost a game. Ah, so we've got a huge problem here, which is that this should contain at least one of the current pictures, because otherwise it would be an otherwise this player can't actually move, because none of these 4 icons actually match these ones. So what I'm going to do is just forcefully replace one. So every time I call gen icons, I can provide, oh, hey viewer, how you going? I'm just writing a game right now. Here's where I'm up to. The idea is that this is player 1, this is player 2, and then you have to press either W, A, S, and D for this player, arrow keys for this player, and then it will swap out these icons for the middle one, and it will change a score. If you press the wrong key, if you press this square, for example, it won't actually match with any of these up here, and you'll lose 2 points. So I need to draw the score, so let's just do that right now. The idea is that you should be able to write this game on a single bus ride. So it's been about an hour currently of me writing this game, which is plenty short enough for a bus ride because it's almost playable. So let's get on with it, shall we? So to draw text, we're going to need this font library. On my bus ride, I'm assuming you have no internet connection. So before you get on the bus, you should have installed Python, Pygame, and also the Pygame documentation. So let's go. Font has a thing called font. So I'm not real sure how I'm planning on getting a font. I think I might just cheat a little bit at this point because I used to remember how to do this. Let's have a look. Font. There you go. There's actually a function called get default font. I'm just saving your time because otherwise it would be boring me finding out that there's a function called get default font. So what we're going to need is the font, the default font. So I'm going to go pygame.font.font. So I'm going to make an instance of that with the default font. Hopefully that should run. Nope, it probably takes a font size, I imagine. There we go, size. Alright. So the font size will be like, I don't know, 16. And then when I want to draw the font, I should be able to just go font.render. So this is what's so great about Pygame, because everything is a surface and it makes it really easy to prototype stuff. Because the screen is a surface, the pictures that are loaded from the PNG files are surfaces, and when you render some text, it gives you a surface. And what do you do with the surface? You blit it onto the screen surface, and then that's how you draw the text. So let's just do that. Font.render. I'm going to say ASDF, and then I'm going to tell it that it needs to be anti-aliased, sure, and then also it needs a background color. So I'm just going to be lazy and make that white. The color of the text, not the background color, sorry. So I'm going to call that 0, 0, and 0 to make a black rendering of the font. So I'm going to call this text image, and then I'm going to go screen.blit text image at the top corner. Let's have a look. Didn't work. Blot is not blit. There you go. ASDF in the top corner right there. Easy enough. You just have to know that there's a thing called get default font, and then in the documentation it's pretty obvious that you need to pass in a font size. You assign that to a font, and then you can use that to render pictures of text. And then once you have the picture of the text, you can put it wherever you want on the screen. So I'm going to make the last coordinate, I'm going to make the last index of this offset thing, like the offset of the actual text for the score. So let's have a look at 150. This is the laziest way to do anything. You know what? I'm going to put it in its own variable. Score offset is that. So when we want to draw the score for each player, I go font.render, and then we're going to use Python 3's f strings. So we're going to go score is player.score, and then I'm going to tell it that it should render it at 16 in size. They left. What a shame. Score offset. Score pause. Score text. Image. And then I'm going to go screen dot lit the score text image at score pause. And we're going to have the same problem as before because you require integer coordinates. So let's just go score pause. There you go. Hopefully you should be able to see the score now. Didn't work. Render takes a color argument. Let's do that. Alright, look at that. Score 0, score 0. If I press up, score 1. There's no play button on the right player. So let's press up again. There you go. I lost 2 points because I guessed wrong. So, yes. I was going to modify gen icons. So gen icons needs an argument to say to make sure that at least one of the items that it returns is one of the items from a list that I pass in, existing icons. And then I'll default that to none, so you don't have to pass it in. But if you do pass it in, if existing icons is not none, as Python is very English. Whoops, did I just try and run this code? Yes, I did. So if I go existing icons, if I can index it at some random index, from 0 to 3. No, I'll go 0 to len of existing icons -1. Alright, so that'll get me a random existing icon. And then I'll get a random index of new icons and just straight up replace it. So that will just force one of them at least to be correct. So new icons at something equals existing icons, and that something is a random number generated by randint. New icons length. Yep, that's fine, whatever, hard coding stuff here and there, but the bus ride is well on its way and I need to get it over with. So you should be able to see as soon as I say gen icons. Yep, as soon as I generate some icons, the first thing I do is go current icons equals gen icons. And then I create 2 players. Each of the players will need to know about the existing icons. Existing icons. Because the initial state needs to reflect a valid state, needs to be a valid state. So it's going to need to know about these existing icons when it calls gen icons when you create a new player. And then it's also going to need to pass it in when it creates the new set of icons right here. So it creates new current icon, or it swaps out the current icons, and then it generates some new icons where at least one of them will be one of the current icons. Didn't work. What have I done? I bet I wrote something bad here. I put a list. Okay, there we go. So now it should be valid at all times. So no matter what, there should be a valid thing. So I'm just going to mash the keys, and if it stops working, then that's pretty good proof that it's not good, but it seems to be pretty good. Turns out statistically I can pretty much balance on 0. No, I went down to 30 just then, but I was almost around score 0. Alright. Let's get rid of that ASDF at the top there. Yeah, okay, so let's call this, let's add another one called score change. That tells you how much your last score was worth. I think this will be important. So I'll go player.scoreChange equals -2. And then I'll say player.score plus equals player.scoreChange. And that makes it a little bit nicer because I can say that it's +1. Okay, so, and then I'm going to use this score change to actually draw the score with different colors. So player.scoreChange, I'm going to go color is just black by default. But if the score change is less than 0, that's a bad thing. So I'm going to go color is red. But if it's greater than, if it's greater than 0, then the color is green, RGB. Green for good, because you succeeded. So I'm going to set that to color. And now it should turn red when you do something bad, green when it does something good. So you can see the green right there. Let's make that font a little bigger. It's kind of small right now. Oh, that didn't even change anything. What's that number that I just randomly changed just then? Ah, the Boolean route presenting if you intend to anti-alias your text. There we go. I'm going to change that score offset a little and make it slightly more to the side. There you go, it's basically centered. So how's our bus trip going? I'm assuming like a 2-hour bus ride. That's like minimum if you're going anywhere reasonable. So now if we press a good direction, so sometimes I get these duplicate symbols. I'm not sure that I really want that, but it doesn't really matter. So, yes, whatever, I broke it. It doesn't really matter. It's still a playable game. So now if I press a bad direction, so a symbol that doesn't exist at the top, like the speaker, I'll press A. Now I lose points and the score turns red. There you go. We've already got a playable game. And so if I press up on the player 2 on the right, then we have a game. And that's pretty much it. Well then, hello viewer that just turned up. I think I just finished making a playable game in a very short amount of time using Python and Pygame. So one major problem with this game right now is that it uses while true with no weighting whatsoever. So if I open up my task list, you'll see that it's using like 3% of my CPU just running. It's not that bad, but when you're trying to save battery life, obviously this is my streaming program, but Python 3, you can see, is taking up 3% of my CPU time, which is going to use up a lot of battery if I'm on a bus. So, one very workable solution that I have come up with for this. Pygame doesn't give you a thing that waits until there's events and then gives you all of the events, but you can just fake it. Let's have a look. We have a function called wait, which will give you a single event from the queue, and it will wait until there is an event in the queue. But we want all of the events from the queue. So the trick is to go events is actually a list of just wait. And as soon as wait returns, you'll get a list of one event. But if there are still other events in the queue, we can just add them on. So you can go events plus equals event.get. And what that does is it will wait for one event and keep it in the list, and then it will get the rest of the events. And it'll run the rest of the loop and then wait for another event. So that means we have a waiting loop that doesn't have to render lots of times just to get all the events. So now if we run it, hopefully, if I open up my task manager, you shouldn't even see Python anywhere. Nowhere to be seen. Not even visible anywhere. Python is just sitting there doing absolutely nothing. So that's so much better for your battery life when you're on the bus or the plane. But the key presses still work, and I can lose at this game. There you go. So I have an entire game. Obviously I have this problem where I get these duplicate icons. I got two phones there. You're not supposed to be able to get two phones. So let's fix that, shall we? So I'm just gonna make this, geez, I don't know. I'm just gonna do some sweet hacks. While true, I'm gonna add this into the list. So if existing icon not in new icons, then stick it in. Otherwise, and then I break out of that while true loop. Otherwise, it will just keep looping, trying again and again and again. Oh, that's such a terrible idea, because if you don't pass that argument in, then it'll loop forever. Okay, while true. Keep generating new random selections of this until it finds one that isn't in new icons. And that's it. So hopefully, if I try that again, no matter what I do, there should never be duplicates. Never duplicates. Good, but there's always guaranteed to be at least one icon from the list at the top. So you'll see I've got stop, play, magnifying glass, and speaker, bell, square, magnifying glass. So if I press speaker, note that the top will become square, magnifying glass, speaker, play. There you go, square, magnifying glass, speaker, play. And that's that. It's an entire game written on a bus, and now I can put the computer between mine and my wife's laps. Oh, did I break the game? And I can play the game. Except obviously, a game written in an hour will probably have bugs. Lots and lots of bugs. So I just hit while loop. It's probably that while loop I just wrote. 248. 22, line 22. Let's have a look. Right. Look, I actually don't care about this enough for this to matter, so I'm just gonna straight up force it after a certain number of loops, I think. Because what happened is that the 4 icons matched exactly. Eventually, we get into a state where speaker tick phone and square, speaker tick, no, speaker tick phone X. Oh no. I think what's going on is that it managed to generate exactly the same list internally. And so now it doesn't know what to do. So I'm gonna just try it at least a few times, and if it doesn't work, oh, this is so gross. If it generates the same list, look, I'm gonna have to make some tricky code here. So if, oh, geez, I don't know. How do I detect if they're both the same? Let's just do something really cool. Which is sort both lists. No, that's a terrible idea. Okay, let's come up with a better one. I mean, the game's basically done at this point, so I could just stop, but I'd rather not, because it's a fatal flaw in the game. So let's just fix it. Keep trying is false. But I only set keep trying false if sorted new icons is not equal to sorted existing icons, or existing icons is none. There you go. So I'll just keep regenerating new icons over and over until, yeah, there we go. Hopefully that will be enough to stop it from having infinite loops. It's always playable and there are never duplicates. That's great. Never duplicates, always playable, which is what you want. Nice! How good is that? So, this is basically a successful project, I would say. The bus ride's already over at 1 hour 20, and you can already play the game. Or maybe it's an hour and a half, and you get 10 minutes to play your amazing game. I think when the score goes below a certain number, it'd probably be reasonable to like restart the game or something like that. But it doesn't really matter. You can just kill the game by pressing escape, but I didn't program that yet, so let's add that. If event.key is pygame.k underscore escape, then running equals false. Whoops. Else. Escape. No, didn't work. Self.running, of course. There you go. Done. A complete game in a pretty short amount of time without actually needing the internet to write it in. And it uses up almost no CPU, so therefore you can play it for hours and hours. If you had like a 12-hour plane ride, for example, then yeah, like those exist. Unfortunately they do. If you're on one of those plane rides, if you wrote this at the start, then you can just play it for the rest of the time, assuming your screen's backlight doesn't waste all of your battery. And so I think that's pretty much enough for the stream for today. Okay, so that was the end of the stream. I realized later that I actually had audio problems at the start of the stream where it was recording the output from my speakers as microphone input. So every time I said anything, it would go around in a big circle and you would hear my voice over and over and over again. So I cut out a big chunk from the start as well. But that's okay because it wasn't really necessary for you to see it. Please subscribe to me on Twitch and Twitter and YouTube, and please like this video. Thank you.